Okay. So, I think yesterday we did the first one up on the board, is that right?
Yes.
Let's do the first one again, just to make sure. Let's see if I say. So this is where we said, if you replace a letter with a value, you really should put it in parentheses. -3, right? Yeah. So that you preserve what's going on. It's supposed to square all of A. So if you don't put parentheses, you're not really doing what it's asking. Y was pretty good. 5. Is it this way around? Yeah. So we did this one yesterday, but just to catch everybody back up. Negative times negative is positive. And then 3 squared is 9. And of course, so I do exponents before subtraction. I do in the parentheses before subtraction. Okay. And then of course here, you can look at this 2 different ways, and both ways get you to the same place. You can either say 9 minus, and then 5 times -5 is -25. Is that cool? Everybody with me? And again, just to remind you guys, I love questions. And if you have a question about something, at least 10 other people have the same question. So feel free to ask away. Is everybody good? Yeah. This is not the only way you can do this, by the way. And then minus and negative is? Plus. I always look at minus and negative as forgiving debt, which is why they cancel. And then 34. Or you could have done this. 9, negative times negative is positive 25. And it gets you to the same place. How are we doing so far? Is that all right? Okay. A little bit, though? So this is all about plugging values in. And then what takes over is PEMDAS. And it's really sad to me. This isn't sad, but are any of you guys on the Facebooks, on the internets? Right. Or no, is that totally an old person thing now? I don't know. A little bit? No. So every now and again on Facebook, I'll see somebody post a thing about, what's the answer to this? It's a math problem, and then everybody's arguing about what the right answer is. And it's so sad to me because there is one right answer if you know frickin' order operations. And that's why order operations exists, to prevent those arguments from happening. But you have math teachers who don't understand order. I'm like, why are you a math teacher when you don't understand that, which is the grammar of mathematics? That's what PEMDAS really is. So, PEMDAS, of course, parentheses, exponents, multiplication, division, addition, subtraction. These have the exact same importance. You guys with me? Please excuse my dumbass son, deficient algebra skills, or dear Aunt Sally, however you feel. How are you guys doing? Are you all right? Does this sound familiar? Okay. So, for example, what if I had this problem? Here's a problem that I could see on the stupid Facebooks. What do you think the answer to that is? If you think it's 1, you're wrong. I understand. That's why I wanted to stop you from saying it. What are the only operations in that statement? Multiplication, division. What's order operations say to do? Do them as they come. They are at the exact same level of importance. Nobody gets done before the other one. So it's just how they come. What's 4 times 4? 16. What's 16 divided by 4? 4. What's 4 times 4? 16. That's the answer. And if you think, now go with me now, go with me. You got to go down to why this makes sense. If you read this, 4 times 4 divided by 4 times 4, right? What is the only thing you just said is being divided by? What's the only thing that is dividing? 4. If you put these together, that makes no sense. So if I rewrite a division, how could I rewrite it? I could put the thing I'm dividing by on the bottom. Is that cool? 3 divided by 5 is 3 over 5. Let's start there. Is that all right? Right? That's another way to write division. So what is the only thing up here that would be on the bottom? That 4. It's the only thing that I'm dividing by. So I could write it as 4 times 4 divided by 4 times 4. If you write it like that, do you see how there's no way in hell these guys make their own little 16? He's up there. He's down there. You guys semi with me? This one is kind of exceptionally evil because you guys normally try to do division last. And a lot of you guys are going to get me saying division is not last. I'm going to say that on a lot of people's papers. And I don't blame you necessarily as much as I could have, because when you see a problem like this, what are you going to do last? What would you do last here? Division. But watch this. If I write this in a row, I wouldn't write it like this. Actually, that's a funky ass problem. We're going to see why in a minute. I can't write it like those are not the same. Do you guys see why those are not the same? This is whatever this number is divided by whatever this number is. This is 5 minus this minus 9. Not the same. I have to tell it, that's the top. That's the bottom. You guys see that? Okay, cool. So the same idea. Division is last here because everything else is in understood parentheses. Right? So if I had a problem that was like this, is division last? Is division last here? No. Because what's at the ass end of PEMDAS? Subtraction and addition, right? So those would come last. Here, division would be almost first. What would be the very first thing I do? Here. Exponents. Okay, maybe. So we created PEMDAS for the same reason you create grammar, because without it, you can't communicate as effectively. There's arguments about what you mean. So everybody who argues about this shit on Facebook do not understand the grammar of math. And it really makes me sad that some of them are teachers. Get out of the profession. Sorry, I rant a lot nowadays. You gotta excuse me. You guys all right? Beautiful. If I ever discuss anything that you have issues with or questions about, ask, right? Don't let me steamroll past you, because all this is going to be something you need to do throughout the whole semester. Okay, maybe. So let's try another problem real quick together. What about this one? Sure. I like it. And actually, put one more thing. I don't know if you guys are right. Some of you guys are just looking at it. I like that. But maybe you're going to use a video as your total. Put like a 7 minus in front. Ooh, yeah, make it really, really yummy. I know, it's kind of creepy when I say it's yummy, and it's also like, you don't know what yummy means, Joe. That is yummy. What would I do first? For sure. Yeah, 2 minus 4. In the parentheses first. But I get way too many people that know a little too much algebra that actually hurts them. They try to FOIL this shit out or something. Do you guys know what I mean when I say FOIL?
Yes.
Okay. There's no foiling here. You only foil when you can't do the inside first.
Yes.
Right? What am I squaring? Well, I got to figure it out and then I can square it.
Yes.
So what's 2 minus 4? Negative 2. Also, why would I not make this 30? Can you guys see why that makes no sense at all? Where would the 5 be if I rewrote it? On the bottom. And where would the 6 be? So they're not interacting with each other. How the hell can you make it 30? That's not fair. Divided by 5, divided by 30. You're like, whoa, that's not fair. You guys see that? So it's like, they're not just rules to just remember. If you delve into why it makes sense that the rules are the way they are, the less you have to memorize, the more you just do it. Okay, maybe. Okay. So the first thing I do is in the parentheses. Next thing is exponents. So what's negative 2 squared? 4. Of course, why did I make this so evil? I made it without even thinking. Let's make this something without bringing fractions in yet. Can we? Is that all right? I should have probably just thought for a second. Can you make this 5 become a 2? Just because. We'll talk about fractions here in a minute. I just don't want to talk about them yet. I don't want to mix things too early. So now what would I do next?
Divide.
Divide, right? You definitely do this. From the very beginning, you can identify that as the last thing you do. Because it's the very last part of PEMDAS. Right? What's at the end of PEMDAS? Subtraction, addition. So I know I'm doing that sucker last. 7 minus, I don't know yet. So what do you get? 4 divided by 2? 2. And now what do you do next? Multiplication. 7 minus 12. Yes?
On the third line, does it matter if you divide or multiply this?
It totally does. If you multiply these first, then you have 4 divided by 12. Which is not what the problem wants you to do. The problem only wants you to divide by 2. Do you see that? I really want you to see that. You have to be able to see that. And again, in my head, if I rewrote this, it would look like it's 7 minus 4 divided by 2 times 6. 6 is over what? Right? So you would not multiply 6 times 2. They're on opposite sides. Do you see that? So you've got to stop. Your brain is going to see 2 times 6 and say, that's 12. I got that. And you're going to go, brain, slow down. I can't do that shit. I got to do multiplication division as it comes. Why does that rule make sense? Because of this. So do I have to write it like this? No. But I can use this idea to remind me why the rule makes sense. Okay, maybe. And then, of course, what's 7 minus 12? You know the quick way to do, I always talk about money with this. If you got $7 and you owe somebody 12, can you pay them off? How much do you still owe them? I owe them 5, yeah. So make it in terms of money. Normally we can deal with that. Also, here I got 7, and here I got negative 12. They're different signs, right? So whenever the two things I'm trying to put together are different signs, I subtract them and put the sign of the bigger one on. What's 12 minus 7? 5. What's the bigger number? 12. I put that sign on it. Maybe? Have you guys ever heard that rule? Do you guys not like to interact with him? Yes? No. Everybody cool with what that symbol means? That's not a decimal, right? That'd be down here. This symbol means multiply.
Yeah, multiply.
Yeah.
What do you do for number 4?
What? I'm sorry. Do it again.
Number 4.
This?
Yes.
Where do you go in the equation?
4 divided by 2 is? 2.
2. Okay.
Yeah, is that cool?
You divide.
Because at this step, what was the next thing to do? Division. And again, if you guys didn't hear what I said yesterday, or it didn't stick out to you, this could easily be PEMDAS, right? Which almost sounds like, you're charged with PEMDAS. I don't know. You kind of with me?
Yeah.
But which one's easier to say? Freaking PEMDAS, right? So there's no, the reason I write this way is because these don't have any dominance on the other. They're at the same level. They do it as it comes. You don't multiply before divide. That's not what that says. You guys with me? Some teachers get that wrong. And if that's ever happened to you, I'm sorry. On behalf of my profession, I'm sorry. But I really want you to see why the rules make sense. Not just memorize them, why do they make sense? Maybe? I like it. Some of you guys are like, I ain't doing that shit. Just tell me what to do. Damn it. All right. Everything we do in math has to make sense. It actually has to. So don't just accept that's what he said to do. That's what I'm going to do. Right? If you've ever been completely why do I do that shit? Bring it up to me, please. That's what I live for. That's why I do this. You guys with me? Yeah. I don't mean to be overbearing if I am. I just want you ask me anything. Right, about math. Keep it narrow focus. All right. Okay. So let's see, what's the next thing here? getting into, okay, what about this guy? So here's the order operations problem I gave you on here. I'll use a different pen. Poor little black dude is dying. I love 4 minus 2 for some reason. 4 minus 2 squared. Was that divided by 2 times 3? What happened to my poor little 3? Poor little dude. Whoop. Okay, that looks almost like the one we just did, right? The thing you have to stop yourself from doing is putting divided by 6, right? That doesn't make sense. They're not on the same level. They can't combine like that. So what's the very first thing you do here?
4 minus 2.
Parentheses. I love it. So 3 plus 2 squared divided by 2 times 3. 3 plus 4 divided by 2 times 3. See how the 3 plus is just going to keep repeating because it's waiting for its turn. Poor little dude. 3 plus 2 times 3. 3 plus 6. 9. Sweet. Okay, I like it. Okay. And by the way, if there's a wide range of backgrounds in here, so if right now you're like, this is easy shit, just appreciate it while that's true. Right? I like it. I say sometimes I'll say, if I'm going too fast, slow me down. If I'm going too slow, deal with it. Sweet. Okay. Oh, we're slowly approaching the fraction problem. And normally fractions are sort of like on the same list as word problems with the level that students like them. But here, before we get there, we got this problem. What's the main idea behind 2b?
Grouping.
Just combine like terms.
Yeah.
Like terms.
Like terms. There you go. You're thinking way ahead. You're thinking about factoring. We're not there yet. Yeah, you can, now please, what does 5x by itself mean? Don't say 5 times x. What does 5x mean?
5 times the unknown number.
No, don't say 5, don't say times. Don't say multiply it. No. 5x is doing what? I love it. You guys are like, I don't know what they're doing, man. There's some room by themselves. Who knows what they could be doing? 5x by itself means x plus x plus x plus x plus x. Some dude in history, this is like the drunk history of math, but it's not that far off. We didn't want to write, what if I had 80 x's that we're adding? He's like, I don't want to write all that shit. Let me just tell everybody, if I put a 5 in front of x, that means 5x is adding. And it's shorthand. So the rest of us just have to catch up with the shit that they did and set as in stone, right? The one guy didn't like it, they killed him. It's different times. What does this mean, just to get a little ahead, but there it is. X times x times x times x times x. So we kind of replaced the operation directly showing up with a number that says how many times that operation is happening. Does that make sense? So the 5's in front, if it's a coefficient, it's addition. If the 5's up here, it's multiplication. And it really just comes down to math people being a little lazy or frugal with their time. I don't know, whichever way I'm saying. So if I have 5 x's adding and I take away 2 of those x's, of course I've got 3 x's left. That's all that's doing, right? I can't put 5x minus 3y. What the shit is that? Don't tell me you got 2 xy's. I didn't have any xy's. Do you see that? So 5x can go together with negative 2x, it's 3x, and then these two can go together because they're just keeping track of the y's. Yes. So I got positive 7 y's left. So all we did was 5 of these minus 2 of these is 3 of these. Right? If we got negative 3 and I add 10, I get 7 of these. Right? I owe somebody 3 y's, but then I found 10 y's. Holy shit, I got 7 y's left over. Yay. Okay, maybe. Now, to be honest, now watch this. This is really cool. See if you guys agree with me. So watch. So remind me, 5x minus 2x is 3x. 5m minus 2m is 3m, right? And then you're like, holy shit, how many times are you going to do this? 5 happy face minus 2 happy face is 3 freaking... Okay, we get the idea, Jeff. Okay, so watch this. 5 ninths minus 2 ninths is 3 of these, right? And then, of course, you can do one more step, but just let's focus on what we just did. Why do fractions need like denominators before I can add and subtract them? Because otherwise they're not like terms. 5 of these minus 2 of these is 3 of these. Bam! Right? And of course, what could I do with that just to get a little ahead? Yeah, you can divide top and bottom by 3 and reduce it. Is that cool? Just happened to be that way. So what if I had 5 ninths minus 2 thirds? I can't, it's like 5x minus 2y. The way it's written, I can't do shit with it right now. But how do I make both the denominators the same? Yeah, what's the LCD going to be? 9. So then what's this guy need?
6. 3 times 3 is 9. 3 times 2 is 6.
Oh, what's he need? Sorry. Now what's it going to become? So he needs a 3.
Oh.
Okay. I love how you look at me like, my math teacher doesn't know numbers. I do. And so I get 5 ninths. So he needs a 3, top and bottom. So then it becomes 6 ninths. And then you can do it. 5 of something minus 6 of something is?
Negative 1.
-1 somethings, right? So -1 ninths. How you guys doing? You ever looked at that way? If you understand like terms, you have to understand like denominators. Why they're needed, how they work, because they work the exact same way. Yes, maybe? So I know it's a little bit of a mystery sometimes. Why do we need like denominator? When do I need a whole? When you're adding, subtracting fractions, you have to have like terms, or else you can't do shit. Yes?
So when you're adding or subtracting, you only have to multiply on one side, and then division and multiplication is both? Or?
Okay, wait a minute, let me catch up. So we only had to change one denominator here. Is that part of what you're asking?
Yeah.
Obviously, if this would have been like a 7, I can't multiply 3 by something nice and make it become 7, so then I have to multiply both.
Okay.
So I just need to do whatever I have to do to make the bottoms the same, whatever I can legally do. Okay, now, I was thinking about going here, but since you asked me, I will go here. What about if I multiply or divide two fractions? Well, let's start the same way. What can I multiply? Can I add x and x squared? Why not? Because they are not like terms. You with me? If I add x squared plus x squared, that's going to be, ooh, this is good.
X cubed.
No, come on.
2x squared?
2x squared. That's all addition can do, is accumulate what you see. I see an x squared, I see another x squared, so how many x squareds do I see? 2 of them. So if you tell me the answer is x to the 4th, I'm going to be like, I don't see any x to the 4th. How did you get? No, what I see is 2 of these. So when I add, subtract, coefficients can change. So I cannot do this, right? How can I accumulate stuff if I have 2 different kinds of things? So I would not be able to simplify this. They're not like terms. Is everybody with me? Where's he going with this shit? Here's where I'm going. What is x times x squared? You guys know. What does x squared mean again? X times x. So what is x times x times x? X to the 3rd. Yes? So multiplication division does not need exactly like terms. It's a little less restrictive. So how do I multiply 2 fractions? So if I had 2 ninths times 3, what, Jeff? Fourths, yeah. Do I need to make an LCD? No. Why not? Because I'm not adding or subtracting. I don't have that restriction on me. When do you need exactly like terms? When you're adding, subtracting. When I'm multiplying, dividing, I don't need exactly like terms. So I could do 2 times 3 over 9 times 4, but what's a little bit better thing to do here?
Cross multiply.
What does this mean?
Multiply.
Times. And what does this mean?
Divide.
So things should want to cancel because I have opposite operations. Anytime I have opposite operations, something could possibly cancel.
Bring the 4 to 2 and then bring the 9.
Yeah, 2 goes into 2 once, 2 goes into 4 twice.
3, 9,
And then 3 goes into 3 once, 3 goes into 9
3.
3 times. Just like we did 3 over 9 earlier, we made it 1/3. Didn't that just become 1/3?
Yes.
And 2 over 4 is 1/2. So then what do I get? 1 over 6. Right? What's a half of a third? 1/6. Gets even smaller. Maybe. I might be throwing a little too much at you, but I really want you to see how everything's kind of connected. Like terms kind of runs through everything to a certain extent.
3 multiply 3. 3 multiply 2.
What would happen if I didn't reduce?
Yeah.
You ready? So I would have gotten 6 over 9 times 4? 36. And then 6, what can you put into both of those?
6.
So divide by 6, I get 1 over.
6.
Oh shit. Yeah.
Okay.
Much easier to reduce first than reduce second. Because then I have smaller numbers to work with, right? Now this wasn't that bad, but you can imagine I can make this 20 and this 98, and holy shit. Then you definitely want to reduce first. Maybe. Okay. All right, let's see. Let's get back to the sheet. Let's keep on track here. So again, do not let me steamroll over you. We will come back to fractions a little more later, but I wanted to get some of that out there now. Where do we? Oh, here's a fraction. Okay, so part C should not be too evil now. I want to really show you guys why this works the way it does. What is 15 if you break it down?
5.
5 times 3. And 45 is 5 times
9.
9, right?
Yes.
So see how the 5s, what do the 5s do? Cancel, right? Because it's 5 divided by 5. And then how does 3/9 reduce? We've done that a few times, yeah. Right?
Yes.
So all you're doing there is you're killing the thing that's repeated because it's not needed. If you double the top and you double the bottom, well, that would cancel back out. You didn't really do anything. Right? So if I 5 times the top and 5 times the bottom, that cancels back out.
Cancel number 1. Like here, you cancel number 1. You write number 1. Number 1.
Yeah, there it is. But I mean, 5 divided by 5 is 1. What's 1 times 3?
3.
Okay, so we don't have to write the extra one. But if it's the only thing left, then I have to write it. I like it. So the little 1 dude is always there, right? So when I write x, what all is there? There's a 1. There's a 1. There's a 1, right? It's surrounded by shit. We just say, okay, we know it's there. Okay, maybe. Which is why, what is x divided by x?
2.
What's 5 divided by 5?
1.
What's 6 divided by 6?
1.
So what's x divided by x?
1.
1. I love you guys so much. Because there's a understood 1 here, right? So when the x's die, what's left? Just that 1. That's when he shows back up. When there's nobody else there, he's got to show up. Maybe. Okay. Oh shit. I need a cameraman. That's what I need. Okay, I think I'm catching the whole thing. All right. Let's see. What's next here? What time is it? Oh yeah, today's a longer day. That's nice. I think we'll take a field trip tomorrow. Is that all right? I mean, you're like, it's your class, dude. We'll follow you around if you. Okay, so we're gonna take a field trip tomorrow. Oh, here's a good one. Why is this one different than, for example, why can I not? I definitely cannot reduce the 2 and the 4. I cannot do it.
It's not multiple.
Yeah, you don't have opposite operations. You have division and subtraction. Do they kill each other? No. But I understand your brain goes, oh, look at that shit, we can do that. No, your brain stop. It's a minus, not a times. You see what I mean?
No.
So you do have to be aware as you do things, because we're human, we're optimistic, right? So what do I have to do here?
Look for
Common denominator.
LCD.
LCD. Much easier to say than common denominator. So what would the LCD be here?
20, 5 on the left side and 4 on the right.
And let me say a phrase that, let's see if you guys get this. What does a prime number mean? Not, this isn't it yet, but what's a prime number?
I didn't say nothing.
You didn't say nothing? Somebody did.
Who's back there?
Oh, it can only be divided by itself and what? I like it. So 17 is prime because you can only break it up as 1 times 17. Let me say this phrase. Let me see if you guys get this. 4 and 5 are relatively prime. To each other, do they share anything with each other? No. Whenever you have denominators that don't share anything, the LCD will be 1 times the other. If this was an 8, would the LCD be 32? No, if that was an 8, the LCD would be a freaking 8. Because 4 could become 8. 8 has 4 in it. So what's the 1 time the LCD is that times that is when they are what's called relatively prime. They have nothing in common with each other. So they both have to, they're both missing each other. Oh. So to get the bottoms the same, this guy needs a 5 and this guy needs a 4. And then the bottoms are the same. So then you get
20, 4 times.
15 20ths minus, oops, got it. 8 20ths is
7.
7 20ths. Sweet. I like it. Okay, gas. Yes.
When it comes to testing, do you want us to write it out that way? Like the way I did it was I put 3/4 and then below it 2/5 and then I like.
Oh yeah, you're fine. You're fine.
Okay, so it doesn't matter.
So formatting very rarely is a problem with me. Not showing enough work is. The first test, by the way, I don't think I've said this yet. There's going to be a part 1 where you don't have a calculator allowed, and a part 2 where you can use a calculator. I like it. You with me? So yes.
Yes.
Okay. But I always want work shown, even if I let you use a calculator. I want some work shown. Okay, I like it. Okay. This one's not too bad because we've already done one with more shit around it than this. But the big thing that the biggest mistake people make here is to say that this is 6 squared. I like the look I'm getting. Some people are like, how the hell would you do that? And some of you guys are like, that's what I thought it was. How many 2s are up here?
1,
How many 3s are up here?
2.
How could you make 2 6s if you just have 1 2 and 2 3s? Right? And of course, okay, maybe nobody did this, which would be awesome. Because that's the biggest mistake with this is somebody writes 6 squared 36. But what do your order operations say to do first? Exponents. Yeah, 3 squared is 9. 2 times 9 is 18. Sweet. So if you got 18, great. If you got 36, it's bad. Okay.